Good morning all. My name is E. Swarnalata, Assistant Professor from EC Department. I'm working in Guru Nanak Institute of Technology. Today I'm going to give an idea about random variables and the random process in a subject called probability theory and stochastic process. The terminology random variable and random process is completely different. Random variable deals with numerical values, whereas random process also deals with the numerical values but varies with respect to time. Let us have a clear picture on random variable and also random process, types of random variables, types of random process. Let us now deal with a random variable. Random variable. This is one of the important terms in probability theory and stochastic process. Random variable. Random variable is generally defined as a real valued function which is obtained by mapping each and every outcome of a sample space to a real value, single real value. No outcome is mapped to a multiple values. Only one outcome is mapped to one real value. So let me give a small example, then I will give a clear definition so that it will be very clear picture about the random variable. So let me take one small example. This is a very familiar example, very known example. So let me take a small example called tossing a coins. So we can take an example of tossing a single coin, tossing two coins simultaneously. So here all the possible outcomes of a random experiment is called sample space. So it is represented as capital S. Capital S is nothing but set of all the possible outcomes. This is what we already know. So for a random experiment tossing two coins, the outcomes are labeled as head, 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 tail, tail, head and tail, tail. These are the possible outcomes when tossing two coins simultaneously. This is one outcome, second outcome, third one, fourth one. All the possible outcomes are nothing but sample space. Now here we will convert this into a random. We will now define the random variable based on the sample space. So let me consider one variable. So it is not a general variable. It is very different from the different algebraic variable. Here it is now called as random variable. How this will be defined? So let me define this random variable now as number of heads. Let me consider as an example of number of heads or count of heads. We can also take it as number of tails or count of tails. So in our random experiment, tossing two coins, we will convert each and every sample space into a real value by taking an example as number of heads. Let me consider one outcome. Head, head. The number of heads contained in this outcome will be 2. Number of heads in the second outcome is 1. Number of heads in the third outcome is 1. Number of heads in the fourth outcome is 0. Here what I am doing is all the elements of the sample space is mapped to a real value. Now all these set of real values comes under single function called a random variable. Okay, this random variable is now containing only values rather than alphabets. No alphabet will be contained in the random variable. Random variable is itself as a real valued function, or we can take it as a sample function. So here how can x can be defined as 0, 1, 1, 2. So now I will define the random variable as set of all the real values. So let me take 0, 1, 1, 2. But as I have already said, random variable contains only one function, one real value. Here number of ones repeating are 2. So I will take it as 0, 1, 2. 0, 1, 2. So random variable is a set of values called as real valued function which is obtained by mapping each and every element of the sample space to a single real value. So this is an example when I take x as a number of heads. Similarly, if I take x as a number of tails, if x as a number of tails. So now h, let me take one outcome of our sample space h. It is containing no tails, therefore 0. ht contains only one tail, so 1. th contains only one tail, 1. And tt contains number of tails count as 2. Therefore, this sample space, elements of the sample space is now mapped to a real value. Okay, so this sample space is now mapped to a real values. Now here sample space is finally converted into X. Therefore, X is now here also written as 0, 1, 1, 2. Finally, I can write X is equals to 0, 1, 2. Now, let me consider the probability, total probability of a sample space, as we know that it is equal to 1. But what about the sample space, total probability of a random variable? It is also equal to 1. Let me show how it is. So, let me consider the probability of a random variable. Probability of X is a random variable. So, what is the total probability of a random variable? How many elements does a random variable in our example contains? 3 elements, 0, 1, 2. Now, this will be labeled as small x1, x2, x3. Now, in this example also, this can be labeled as x1, x2, x3. Now, what is the probability of X? So, in order to find the probability of X, let me find what is the probability of x1, probability of x2, probability of x3. So, what is the probability of x1? What is the probability of x1? x1 is nothing but 0 number of heads. 0 number of heads. How many outcomes are there in our sample space with such an outcome? 0 number of heads. In out of these 4, there are 0 number of heads in this case. That is only one possible outcome out of 4 outcomes. So, what is the probability as per the relative frequency approach? 1 divided by 4. 1 favorable case by total number of outcomes. P of x1 is equals to 1 divided by 4. Then what about P of x2? Let me consider P of x2. What is P of x2? Small x2. What is P of x2? x2 is nothing but 1 number of head. 1 number of head. So, how many possible outcomes are there containing 1 number of head? 1 and 2. 2 favorable cases out of 4 outcomes. So, the probability will be given as 2 divided by 4, which is nothing but 1 by 2. Let me take probability of x3. Probability of x3. So, x3. What is x3? 2 number of heads. 2 number of heads. So, how many favorable cases are there here? Only 1 favorable case out of 4 outcomes. So, what is the probability? 1 out of 4. So, total probability is obtained by adding the individual probabilities of all the elements in the sample space. So, 1 by 4 plus 1 by 2 plus 1 by 4, which is equals to 1. So, therefore, the total probability of X in our case is equals to 1. Similarly, here also the total probability of X or the total probability of a random variable is equals to 1. So, what I mean to say is the total probability of any sample space of any random experiment is equal to 1, and when it is converted into a random variable, its total probability is also equals to 1. Now, how many types of random variables will be there? There are 2 types of random variables. One is continuous random variable, discrete random variable. When can we say the random variable is continuous? When its sample space is continuous or finite number. When it is countable and finite number, it is called discrete random variable. What is continuous random variable? If its sample space is containing countless values or infinite number of values within a certain limit or within a particular limit, it is called continuous sample space. If a sample space is discrete, it is called discrete random variable. If a sample space is continuous, it is called continuous sample space or continuous random variable. So, let me take a small example. Rolling a die. Rolling a die, picking a balls or tossing a coin, all these sample spaces or discrete sample space. So, therefore, random variable also will be discrete random variable. So, for example, rolling a die. Rolling a die contains all the possible outcomes like 0, 1, 2, 3, 4, 5, 6. 1 is the number of value or the face present on the die. 2 is the number or the face present on the die. Likewise, there are 6 possible outcomes on rolling a die. So, x is equals to 1, 2, 3, 4, 5, 6. It is taking countable value or finite value which can be counted. So, this is called discrete random variable. Whereas, if I take for example, x is taking the range 0 less than or equal to capital X less than or equal to 2. This is taking infinite number of values or countless values, that is x is taking countless values within the range 0 to 2. So this is called as continuous sample space. Like for example, 0 to 2, how many possible values we can take? 0, 0.1, 0.2, 0.3, 0.9, 1.1, 1.9. Likewise, which is countless or infinite values. So such an example is called infinite sample space or continuous sample space. Now, this is a clear picture about random variable. Here, whatever the examples we are dealing, it is not varying with respect to time. When you toss a coin now, it will give only 2 possible outcomes. When you toss a coin after 1 hour, it will also give 2 possible outcomes then also. Then after 1 week, the same possible outcomes, but random process. Now we'll come to the random process. Random process gives the outcomes which varies with respect to time. Random variables does not varies with respect to time, whereas random process varies with respect to time. So random process can be defined as it is a function of both variables like sample space and time. So here now coming to the random process. Random process is a function of both sample space and time. It is simply represented as x of t. So now we are dealing with random process. Random process. The other name for random process can be stochastic process. The other name for the random process is stochastic process. So random process can be defined as a function of both sample space and time. That means if a random variables varies with respect to time, or if a random variable is a function of time, then it is called random process. Till now we have taken the example for random variables as tossing a coin, rolling a die, picking the marbles, picking the balls. All these comes under random variables. Now what examples can we consider for random process? For example, number of calls a customer care can receive in an hour, or number of customers approaching or arriving to a restaurant in an hour, or the temperature reading for a particular hour from 3 to 4 or 12 to 3 or in the morning sessions, whatever it is. So the temperature will be varying with respect to time, from second to second, minute to minute, there will be variation. Such an example is the best example for the random process. So we can say random process is nothing but it is a function of both sample space as well as time. If a random variable varies with respect to time, it is called random process. So the best representation is nothing but noise signal. Noise signal in any electronic circuit, you can take it as a best random signal. Similarly, temperature reading. So here how to represent the random process? How to represent the random process? Let me consider the x-axis as a time function and the y-axis as an amplitude. So amplitude here I am just representing as x of t. Okay, so whenever you are taking, for example, in the afternoon 1 to 2 around 1 p.m. to 2 p.m. let me mark every 5 minutes the temperature values. So at initial point, next after 5 minutes, after 10 minutes, after 15 minutes, after 20 minutes, like this, after 60 minutes, that is around 2 to 3. Okay, so after every time. So at 5 for example, there will be one temperature reading. At 10 o'clock, after 10 minutes, there will be another temperature reading. After 15 minutes, there may be another temperature reading. So let me mark all these, and there will be some random signal like this. There will be random signal like this. So here, how it is a function of sample space and how it is a function of time. When you look at this example, here the temperature here is different. Let me take this as a time t1. The temperature reading is here different. This is, for example, at time t2. This is another temperature reading at time t3, so on. So here, whatever the temperature value is there, here it is called as random variable x at t1. X at t1, so simply I will represent as x at t1. This is another temperature reading at another time instant t2. So this is represented as x at t2. This is now represented as x at t3. Now all these set of elements now indicated as random process. So now finally how the random process is indicated as set. So random process x of t is equal to x1, x2, x3, x4, so on. So what does x1 means? X at time t1. x2 mean x at time t2, x3 mean x at time t3. So here finally we can say random variable. So this is sample space which is varying with respect to time. So simply called as random process x of t. How many types of random process are there? There are 4 different types of random process. There are 2 different types of random variables as we have discussed earlier. So what are the 2 different random variables? Discrete random variable, continuous random variable. Now how many types of random process are there? Completely different to that of previous one. So here there are 4 different types of random process. Continuous random process, discrete random process, continuous random sequence, discrete random sequence. Thank you everyone.